So somebody help me out. I am in eternal need of help. Can somebody, oh crap, I never did that. It's okay, I'll get there. Could somebody, there's a Venn diagram. Whoops. Come here. I guess. Gather, go here, unfreeze. There. Right? That's a Venn diagram. Not the best Venn diagram in the world, but it'll do. My universe is leaking down here. Okay. So, what if I ask you to, are A and B, all right, let me ask you this way. Can you draw a Venn diagram where this is true? Oh shit. There we go. The projector says, let me up the difficulty.
No.
What does that mean? No. What do you mean you can't? Of course you can. Can somebody tell me what that says? Is empty. What's that symbol mean? It's and. What's the other name for that symbol? Intersection. So this says the intersection of A and B is empty. Which another way to look at it is A and B don't intersect. Can you draw a Venn diagram where A and B don't intersect? Of course you can. Easy as shit. Easy as shit. Did I draw a Venn diagram where they don't intersect? No, they intersect. Can you draw a Venn diagram where they don't intersect? A, B. There you go.
I thought it was no Venn diagram on this picture.
Oh, hell no. No. That's your classic one because most groups have something in common. But if this was salamanders and volcanic rocks, there are no volcanic rocks that are also salamanders that I know of. Right. I used to do cats and dogs, and there's this cartoon, cat dog, where I don't want to think about the biology of it too much. Anyway, okay. So with Venn diagrams, you have a lot of flexibility. This is another valid Venn diagram. That is another valid Venn diagram. It's like A's got a little B baby, right? Aww.
And if to write that other one down, it would be A is a proper subset of B, or B is a proper subset of A?
Oh, for this one?
Yeah, how would you?
Yeah,
how
this
you
would
write that
be, which is a proper subset of the other? In this, and I've gotten away from your question, but I'm coming back to it. Which of these is a proper subset of the other? B is a proper subset. You're right. B is a proper subset of A. Because B is a part of A. There's nothing in B that is not also in A because B is completely in A. It's like a little amoeba ate a little bacteria and now it's in there. This picture, is this true for this picture? Because the intersection of A and B, there isn't one, so it would be empty. There is nothing that is, now watch this, you can read this in English. Nothing is in A and B. So what if the problem said to draw this picture? What do I not want to have happen? I don't want the intersection to be empty. Does that work? Is the intersection empty? Nope. There's something in here, yes? So that would answer this. So if I draw a Venn diagram, what are the people that are in here? What groups are they in? C and D. So C and D is not empty, is it? There are people in there. Yes? Maybe this is cab drivers and people that play D&D. So I bet you a lot of money that somewhere in the universe there's a cab driver who plays D&D. So there's at least one person in there. You guys with me? Okay. So this would mean A intersect B is not empty. That's what that says. A intersect, I'm sorry. C intersect D. Wait a minute, trick myself. Yes? Now if I put salamanders and volcanic rocks, Are there any that are both? No, this is empty. The intersection between salamanders and volcanic rocks would be empty. Is that better?
Yeah.
Okay, so that problem said it doesn't want it to be empty, so then just don't draw it like this. Draw them where they intersect at least a little bit. Yeah. You're welcome. I know these get a little weird. Trust me. Which is one reason why I take questions at the beginning. Anything else from homework stuff? Yes.
On section 2.3, number 17.
Look at you getting ahead. I love it. 17. Oh, there it is. Bless you. Yeah, so alright. Hold on to this question. Because we haven't really officially gotten to section 2-3 yet.
I thought we were supposed to be doing it, that's why.
No, it's beautiful.
That's why I asked.
Do it, yeah. We're just not there yet, okay. So anything else, homework? Okay, I have graded homework. I haven't put it in the spreadsheet. I'm gonna do that in a minute and then I'll give it back to you guys. So today, things are happening. Today we're gonna play with shit. Is that right? Not shit, but we're gonna play with stuff. So these are little, what are called manipulatives. We have a whole series of manipulatives. We'll be doing various things with them. This is gonna be our first foray into base manipulatives. So these are manipulatives related to, I'm gonna first give you manipulatives related to base 3. And I'm just gonna make you do some stuff and we'll see where we end up. First thing I wanna do, let me see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29. Interesting. 29 is a horrible number, I can't divide that nice. Can I get groups of 4 somehow, maybe? That'll almost work. Alright, I need you guys to all help. Can you 4 back here? Yes, maybe you can turn around, is that cool? You 4 are a group. Can you 2? Would you 2 feel comfortable? So then you can turn around, work with them. I like it. You guys turn around, you make a big ass group of 5. You guys back there, you can be a big ass group of 5. You guys 4.
Where are we going? Here?
Let's do this. You guys 4. You guys 3.
Lucky? What are you talking about?
Oh, sorry.
It's like, what? He was like,
Make a little
is this Olivia? What? I said, what's up? She said,
No, you didn't know. I could have possibly be upset. Gaze upon the other.
oh my gosh. Sorry, I just worried about that.
Make a little central space.
She was like, they were playing some sort of game with us. And she was like, and I said, it's cool. You're out. We're waiting for you. I missed it. I'm like, okay. And then I called her. I was like, on the walk. Can you just He's like, oh. No, that's so fair. Yeah, it feels so good.
Alright guys. I am not gonna give you much instruction beyond this. Can you count out everybody? Let me think for a second. Can you count out 17? Let me know if I didn't give you enough. Count out 17. I like it. It's a very rudimentary Jenga. That would be very hard to play. Is everybody with me? Count out 17 of them. Does anyone have a connected?
No.
Alright. You got 17? Everybody got 17?
Oh, wait.
What's up? You guys good? Alright.
I was looking at like.
You guys. Everybody. Separate your. Keep track of your 17. You with me? The other ones at the moment, tell them you mean nothing to me. No, just put them to the side.
It's okay.
A criticism.
Name. It's gonna take longer to pass this stuff.
No heart emoji.
Lenny.
I did not do the math, I just played with it. Like, it's like,
We have the little like plastic bears.
mine were plastic. But like,
We have like the plastic bears and then we have the blue plastic cubes.
So long together that they just join.
What can I say? Wow, years ago, but I was like so.
Did I miss somebody? Did I miss you guys?
True, so
No.
like.
Everybody got the connected 3 now? Okay. And finally, not those, Jeff, these. Okay.
Of all the things.
All right. So guys, you all have these, yes? Everybody's got at least 17 of these. You got 17 of these counted out. You have several of these little dudes. Come back to me. And you have several of these guys. So does anyone understand what this might represent? Base 3. I love it. What I want you to do is to take your 17 and rearrange them so you figure out. So obviously 3 of them become what we call a long. So these are called units. These are called longs. And these are called flats. And just to let you know, there's a level above. Resistance is futile. Okay. These are called, remarkably enough, we're just going to deal up to the flats. So what I want you to do is to try to replace, always maintain 17, but put them together and have the least number of flats, longs, and units to represent 17. You guys with me? So for example, if you put 1 long in place of 3, don't you still have 17? Yes? So I want you to replace until you have the least number of flats, longs, and units. And then I gave you some, oh, I didn't see? That's what I was asking. Because you had it too early.
What are we getting punished for?
Oh, good. That's all you need.
Oh, okay, cool.
One is all you need. There you go. So that's the one you had earlier. I'm gonna take Okay, stay with me now. Can you imagine what would your students, if you were lucky enough to teach young enough, what would they be using? Are you going to teach little tiny humans base 3? They would have base 10. They would have little units. They'd have how long would the long be? 10. So they would understand physically when you gather 10 units, it goes to the next place. It becomes a 1. That's like carrying the 1. Holy shit, right? 9 plus 1, carry the 1. Now it's 1, 0. Are you guys kind of with me? And of course, to them, this is like brain blowing, right? This is like, holy shit. So if I have 17, okay. 4, 8, 12, 16, 17. Okay. I feel like I should be recorded and put on those videos. 4, 8, 12, 16, 17. Okay. So where do you think, I'm not sure if you guys did this slowly enough, but what do I start to do first? What am I thinking ahead towards if I have to regather these together and replace it with other pieces? So currently I have 17 total pieces, which is not efficient.
The piece with the most, like, units is the flats of 5, 9.
Yes, all right. So you could do a variation of this. You could make a whole bunch of longs, and then when you have 3 longs, you could put them together. But if you think, let me start with how many flats can I make? So there's 1 flat, yeah? So I can replace that with this dude. Get out of here. So I still have 17, right? Now I can start making my longs. So now I have 2 longs, so I can replace those. Did you give yourself 2 longs, Jeff? No, you didn't. You're so mean to yourself. Okay. So now I've got 2 longs. And 2 of those. Is this all right? So I got 2 plus 6 is 8, plus 9, 17. What would this number be in base 3 though? How many longs? I'm sorry, how many flats? 1. How many longs? 2. How many pieces? Units? 2. This is 122 base 3. It's the same thing as 17 base 10. You guys with me? We're doing the extra step of translating to our system, but they would just be getting used to our system directly. They'd be using base 10 pieces. So, can you take your longs and your flat and kind of put them in a little stack on this side? You with me? Okay.
You said base 3 is the same as what? What did you say? You said it's the same as...
I didn't say that. 122 base 3 is the same as 17. They represent the same amount of something. Okay. The funny thing about this is it just takes longer to give you stuff. These 3 of those is good. Take 3 of those. Yes, thank you. I'm just kidding.
Just go on the bottom. Oh, yes.
I'm not sure. Mad scientist, I got that. You guys these, right?
That looks just so bad.
Instead of base 2? All right. So let me show you this. Show you the base 10 stuff. So let me ask a question. I want to show you the right visual.
gifter.
So guys, base 10. Oh man, put this in here. There we go. So guys, how can I identify that this is these are base 10 pieces? That's crazy. So if I count these, there's 10 of them here. So the whole idea is if I put together 10 of these, when I get to 9 of these, whatever 9 is there, something like that. And if I add one more piece, it could then make a complete one of these. That is like carrying the 1. 9 plus 1 is 1, 0. That's the first time we go over into the next place. We go into the next dimension. This is a base 10 set because it takes 10 ones to make this, and then it takes 10 of these to make the big old orange dude. And then how many of these orange dudes do I need for the next step up? 10. And then I get one of these. Right? So if you're a geek like me, this is the Borg. Resistance of Utah. But understandably, that might not be the same for you guys. Okay. So how do I know this is base 3? Because how many units do I need before I go to the next place? 3. And how many of these do I need before I go to the next place? 3. Is everybody with me? So what do we know so far? We know 17. Whenever I write a number without a base, we know it's base 10. Because that's how we always write a number. So we want to put a little base 10. That is equal to 122 base 3. It takes 7 1s and 1 10 to make 17. Or it takes 2 1s, 2 3s, and 1 9 to make 17. Yes? You guys with me? Okay. So now I want you to do the same thing but base 4. So everybody's got their base 4 pieces? How do you know it's base 4? I just know, Jeff. Oh. Where did it go? Oh, there it is. All right. This shouldn't take too long, right? What do you guys get? So if I do base 4, and I start with 17 little units, how many of them can you put together to make one of these? Yeah, how many is this? 16. So how many longs do you need then? None, because all I have left, once I make this, the only thing I have left is one little dude, right? That makes 17. So what is 17 in base 4 then? How many of these pieces do I have? 1.
101.
Yeah, 101. So 17 is 122 base 3. It's also 101 base 4. Let me stop for a minute. So our system, we never stop to think about this fact, but our number system, when I tell you a number, I'm telling you a way to combine certain multiples of 10 to make an amount. We don't have to do that because we learned our number system. We understand it. But if I'm looking at base 3 or 4, holy crap, I got to go way back to fundamentals and think, put this many together for this, put this many together for this. Then we have to actually do it step by step, which is what your students will be doing with base 10. Which is why it's good for you to know how to do this, because you're experiencing exactly what they would experience. Now, this wasn't as hard because you have experience with a number system. They will have 0 experience with any number system. So it's going to be even that much more strange for them. Okay, I like it. Now, can you guys put back base 3 pieces? Put the 1, 2, 2 back. 1, 2, 2. Let me get a new fresh sheet. Stay with me. I'm going to go one step further. I am curious what 122 base 3 plus 1 base 3. I'm curious about what that is. And you're all like, well, then you figure it out, man. So, you've got 122 there, yes? I'm curious what you get when you add 1 to it. Physically, what would that mean? Huh? Sorry? No, it's not. It's not. Real quick, let me say this. Can the symbol 3 show up in base 3? In base 10, do we have a symbol for 10? How many symbols does it take for us to make 10? 2, 1, 0, correct? What is the largest single digit we have in base 10? 9. What's the largest single digit I could possibly have in base 3? 2. So, what I want you to physically do. So everybody got this laid out? Take a little unit, that's 1. Plop it right down. Now you're adding 1. You're physically adding 1, correct? Now rearrange it again. And let me know if you need something. No, I'm not going to do it. Let me know if you figure out if you need something. What do you need? You need another flat. You need another flat. Does anybody else need another flat? You guys need another flat? You guys need another flat? Anybody else? You need another flat? If you are doing this and you understand it, you need another flat. So I'm not going to give it to you because everybody needs one. We'll just do it up here. Because I'm mean, all right? So I'm going to physically add 1. The minute I do that, these can become Jeff. They can become Jeff. There it is. You guys with me? I really want this. This is a physical interpretation of adding in our base value system. I can have 4 apples and put 1 more apple, but that's not very exciting. Now I got 5 apples. This is a level up from that. I am physically adding something, but I'm looking at the bases as I do it. That is weird. So if I add this, that becomes a long, and that should go over here. But if I do that, this becomes a flat, and then I go over here. So what number do I have now? So 122 plus 1 makes 2, 0, 0. I love it. If you think about it, what's 199 plus 1? What is 199 plus 1? 2 frickin' 100. So what's 122 base 3 plus 1? 200, because the highest digit is 2. So of course it's going to roll over. You guys? So you physically can see the carrying over. Yes? Let me do it again. I'm getting a little ahead of myself, but I do that shit. Guys, real quick. I really want this to make sense. So if I add 1 here, I carry a 1 to this space, right? But then I carry a 1 over here. And that's how I get 200. So if I overanalyze 199 plus 1, just go with me. If I overanalyze this thing, you're all like, it's 200, man, what the shit? But let's overanalyze it. 9 plus 1 is, oh shit, what do I do? Carry the 1. That was me physically. Jeff, I love you, man. That was me physically putting this in this place, yes? I carried the 1 physically, yes? And then what's 1 plus 9? 10. And then I have to carry a 1 again. So you can physically see the carrying of the 1 happening, maybe, yes? If I wasn't covering up my hands because it's all falling apart. It's a house of cards, Jeff. So 122 base 3 plus 1 base 3 is 200 base 3. Freaky shit. Would you have predicted that to be true? Probably not. Does it make more physical sense to you now? Can you imagine your kids who, if you're lucky enough, they've never seen base 10, except, they've seen numbers, but they don't really have a connection to them? They're going to have the same kind of moments where they physically do stuff and they can see it happening. And that's where they really make connections, when they can work with stuff. Thank you for doing that with me. Can you all please try to gather things in correct little piles? Yes? Here, I'll come around and gather your units first. Do this thing. Almost there. I set you up for failure. He's over there pulling the dude. I'll come back for him. Oh, thank you. Oh no, I messed you up. I tricked you. Yeah, it's like I found some from like 2 seconds. Hey. Oh yeah. I was ready. I was ready.
So that we can learn this and then kind of explain this to go back to learning.
What do we got here? Stonehenge. Is that what it is? And these are little druids. I love it. We had base 3 Stonehenge going on. Let's see. Can I do this less efficiently? I need your long. Base 3 longs. And then base 4 longs. Base 3 longs. Oh, sorry. And then base 4 longs. Base 3 longs. Base 3 longs. Base 3 longs. Base 3 longs. Base 4 longs. So it doesn't matter. Oh, base 3. Alright, and has everybody got 2 flats left? You guys have 2 flats left? I love you guys. There you go. Don't tell them anything. Over here now. Keep doing that to you.
Oh, yeah. Yeah.
Alright, nobody's got anything left, right? Okay. Stay in those groups. Where did I put them? There they are.
See, like, need to remember. Yeah, I know. And I never, I can't always feel like
At least they're good. Alright, guys. Okay. So, in your groups, I want you to read through this. Try to answer what you can, and then we'll go over it together. So I have questions sprinkled throughout. Alright guys, I'm going to catch up to you a bit here. Oh shit. I was supposed to put the homework in, damn it. I'll do that. Oh, by the way, this is really interesting for me because as you guys watch me, it's sort of like when I was a senior in high school, I was in theater. And I actually became a thespian because I stage managed Godspell and I had a lot of help. But when you do any theater and then you go watch a play, you kind of look at different things. You guys are future teachers. You should analyze what I'm doing from a different perspective. Do you understand how it's a little bit chaotic to have a lot of people and then a lot of things you want to do? Do you see what I'm saying? So you guys can watch me and go, well, that's gonna be me someday trying to I want to do all of this with everybody. That's a lot. Okay. So every carton holds 8 eggs. Every crate holds 8 cartons. So how many eggs are in a full crate of full cartons? 64. 8 eggs in every carton, right? And there's 8 cartons in every crate, so that's 8 times 8, 64 total eggs. So if we have 73 eggs, how can you use what you just did to help you start to piece this together?
Kind of do like the Babylonians.
Totally! Sorry, hold on. So if I subtract 64, I could put those 64 and they would fill a crate. So that's 1 full crate so far. And what do I have left? 9. Now I move on to cartons. How many cartons can I fill? 1 carton. So now it's minus 8 eggs, correct? And so I now have 1 egg left. 1 poor little egg. So to come away from eggs and go straight to just numbers, the number 73 base 10 is the same thing as the number 111 base 8. 3 1s and 7 10s is the same thing as 1 1, 1 8, and 164. That's what that says. Okay, maybe. So now, of course, I had to go freaking bring a truck into this. Each truck holds 8 crates. So how many eggs are in a full truck? How many eggs in 8 crates if there's 64 in each crate? Yes, 64 times 8? 512, right? So do we even need a truck for this? Would 500 eggs make a truck? How many total eggs make a truck? 512. Do I have enough? Okay, so let me slow down for a second. Somebody agree that if I would put 8 crates in a truck, and every crate has 64 eggs, 8 times 64 is 512, correct? I cannot fill a truck unless I have 512 eggs. I didn't mean for this to be a trick question, by the way, but it just turned out to be. So do I even get a full truck? No, it's fine. So I have no full trucks. How do I figure out how many crates I need?
Divide 500 by 60.
Yeah, 500 divided by 64. What do you get? 7, roughly, with some extra, right?
Yeah.
So that'd be 7 crates. 7 times 64 is 448.
Yeah.
So how many eggs do I have still left to take care of? 52. You guys with me? So how many cartons could I fill then? Every carton has 8. Yeah, 6. I could fill 6 cartons. That's 48. So I have 4 left over. So 4 eggs left over. So 500 base 10 is 764 base 8. Okay. So in some ways, so I like this example of the eggs. I've been doing this for a while. I actually just made this handout this morning because I never had a handout. I'm like, why don't I make a handout of this thing? Which is why the 500 didn't work the way I wanted to, but too bad for me. In some ways, the math is easier instead of doing it in terms of eggs. So for example, let's do this first one together. Do you see how it's in base 8, correct?
Yes.
That means the plate, yes, go ahead, sorry.
Where'd you get the 448?
Oh, 7 times 64. And I'm double checking in my head, I think that's right, 448, yes. So, help me out. These first three are easier. Do you guys remember when is it easier to convert a number? When we're going from a different thing back to us. That's always easier. So this is like me saying I have 2 crates, 3 cartons, and 1 egg. And I'll put it back together to figure out how many eggs I got. So can somebody tell me the places involved here? What is each of these, what place are they in? 1s, 8s, 64s. And now you just have to put that back together. I got 2 64s. You guys with me? So do those 3. Do 1 ABC. I don't know if anyone's looked at 2C. It's curious about that, but we'll get there. Did I turn that back on? Yes. What's up? I'm sorry. So every 64 eggs would make a full crate, right? So if I had 128 eggs, that would be 2 full crates. So if I just take how many eggs I have divided by 64, I'll get how many crates I can fill. Yeah, and then 7 times 64 is 440. Oh, so so the decimal just means there's a remainder. So I can find, all right, so here, go. So let me see what we got. So 500, if you wanted to, you can do the trick we did, minus 7, and then multiply by what I divided by. So I have 52 left. Or 7 times 64 is 448. 500 total minus 448 is 52 left over.
Okay.
So the decimal just represents the remainder.
Right.
And you don't have to use it at all if you don't want to. You can just multiply it and subtract.
So the remainder matters, but it doesn't matter.
The remainder matters. It completely matters because then it tells you how much. But the way you get it doesn't matter. You either use a decimal like I did, or you can just multiply and subtract to see what's left. If you do 7 64s, that doesn't equal 500. This is how much is left. Well, 7 times 64 is 448. There's 52 left. Then how much can this guy take care of? 6 times 8 is 48. How much is left? Yeah.
Oh, okay, that
Good.
makes sense. Thank you.
Well, I've left my pen somewhere. There it is. What percentage is the range? So guys, let me catch up to you. 75 base, is everybody cool with this? 153? 2 64s plus 3 8s plus 1 1. What are the places for this one? 1 and 9. So I have 7 9s. What's that? 63 plus 5 1s. So if I want to write the number 68, if I want to represent 68 things in base 9, I would put 75. I like it. Q. Is this a valid number? How, like, for example, real quick on the side. Don't even write this down. Is that a valid number? Right there. Is this a valid number? What base am I in? What's the highest single digit allowed in base 6? 5. So is this a valid number?
No.
Nope. If a civilization had a base 6, they wouldn't know what the hell 7 meant. They wouldn't write it in a single digit. Yes? Okay. So this is good. We're base 3, which means the bases are going to be, the places are going to be a little bit easier. So we got 1s, what else? 3s. So let me put 1 0 2 1 0. 9, 27, 81, and then you just gotta put those back together, right? So if I tell you what base it is, and the little subscript tells you the base and the places are filled, you just keep multiplying by the base to get the next one up. So now you just gotta add these together. So now you, is that 101? 102? Good job, Jeff. What did I do wrong? Oh, Jeff, the other one, okay. Reading sports. The reason going from our system to another, the reason that is harder is because the places are empty. I want to go to base 6. Can somebody start telling me what places it has? 1s, 6s, 36. What would the next one be? 216. Is that too much? Yep. So this feels very familiar. Like somebody else said, it's like Babylonians. It's the same kind of work we did for Babylonians, Mayans. This is easier though, because we get to use our symbols now, not pancakes, blueberries, not freaking Pac-Man or little inequality symbols. But these are blank, yes? I really want you to understand, because people do the wrong math at the wrong time. If it's in the base, the places are full. Then I just put it back together. If it's not in the base yet, these are empty. I don't know what they are yet. That's why it sucks. It's worse. Because they're empty, I gotta figure out what the hell they are. I got 121. What do I start doing to figure out how to fill these in?
-36.
Is it only 136 that would work? See, I gotta figure out how many 36s can help me with this. I can do more than 136 in there, right? How do I figure out how many 36s? Divide, yeah. Or you just think to yourself, 4 times 36 would be too much. You guys see that? So it must be 3 36s. I really want you guys with me on this. The way I look at these problems is I have 121 to take care of. And I have these places to help me. So the 36 says, I can help you with this much. And it helps the most it can. So if I only use one of them, that's not the most it can help. If I use 3 of them, that's the most it can cover. And then I say, okay, what's left over for the other people? So what is 3 times 36? 108. So what's left over? 13. So how many 6s? 2. And of course that leaves 1. Now I wish I could say I did that on purpose, but I didn't. So 121 base 10 is 321 base 6. That's a coincidence, by the way, that it ends in 21. That's kind of neat. I like it a lot. So you guys try part B. And then we'll talk about part C. Yeah. I got you. By the way, guys, let me say this. Any damn time I'm talking about anything. If I'm going too fast, slow me down. If I'm going too slow, deal with it. You guys understand? Don't sit there and go, man, just let me know. Because if nobody's asking me anything, I'm just going to kind of keep going. So feel free to go, wait, can you say that again? You know, no trouble with that. Of course. Myself a little more room here. So what's the first step you guys are taking to do the base 7 question? Well, very first thing is you set up your places, right? So this is ones, sevens. What would the next one be? 343, that's too much, right? Remember how I said always go one too much? To make sure you've got enough. So now, like you just said, 49 goes into 121. How many times? Twice. What's twice 49? 98. 121 minus 100 would be 21, so 121 minus 2 less is 2 more, so it's 23. So how many sevens can handle 23? 3 of them, and how much is left? Because the poor little dudes can only do so much. 2. Yeah. So 121 base 10 is 232 base 7. Or 1 plus 2 10s plus 100 is the same thing as 2 1s plus 3 7s plus 2 49s. Okay, I like it. Because the thing we forget about, I'm sorry guys, the thing we forget about is each number in base 10 represents a little math problem. We don't have to do the little math problem because we grew up on it. It's sort of like, I don't have to translate from English to English because it's English. It's what I grew up in. But if I want to do English and Spanish, I'd have to go, okay, translate each step, right? So this is translating from base 10 to base 7. So what the shit about base 16? So let me ask you this. Let me really make sure everybody understands. Base 10, highest single digit is 9. If I want to represent anything bigger than 9, I need more than one place. Base 6, what's the highest single digit? 5. If I want to represent anything bigger than 5, I need more than one place. Let me ask you this. How do I write 10 in base 10? 10. Yeah, 1, 0. How do I write 6 in base 6? 1, 0. How do I write 3 in base 3? 1, 0. How do I write 48 in base 48? 1, 0. Because that would mean 148 and no 1s. So the symbol 1, 0 is 10 for us because we use base 10. 1, 0 for somebody who uses base 7, it would mean 7. Are you guys semi with me? This is trippy. You guys agree with me? It's very trippy. You're like, what the shit is this guy doing? I thought I knew numbers, and look at this guy coming along. But obviously you all know base 10. It's just, I'm trying to expand your mind a bit. It didn't have to be 10. We could have picked almost anything. We just said, yeah, 10 looks good. So, what about base 16? What's the highest single digit in base 16? 15. Now think about what you just said. I can do 1, 2, 3, 4, 5, 6, 7, 8, 9. You just told me that every number up to 15 needs a single digit in base 16. Are you guys with me? Now let me say this a different way. If we had base 7, would the numeral 7 exist for us? So if I have a base less than 10, I don't need as many single digits as we have, right? Because I don't need 7, because it's 1, 0. I don't need 8, because it's 1, 1. Are you guys kind of with me? So obviously, if I go above 10, we ain't got enough frickin' symbols for that shit. I need a single digit for 10 then. You guys kind of with me? What did the Babylonians do though? They just said, let's just cram a bunch of shit in one place. And we're kind of like, that's a little chaotic. I just want one, just like our system, I just want one symbol there, right? Okay, so let me do this. This is not valid, but let me do this. So can somebody tell me what the places are in base 16? 1s, 16s.
256.
Beautiful. And then the next one is huge. I used to know what it was. I forget what it was. Well, it almost doesn't matter. Okay, I'm not going to go that far.
4,096.
4,096. Okay. So if I put this specifically, and I said there was 10 here and 11 there, can you guys tell me what number that is? No. What am I saying I have? How many 16s am I saying I have? 11. Now, I love what just happened though. If I just write the digits out, doesn't it look like there's 4 places? Doesn't it look like there's 4 places? How many places are there supposed to be? 2. That's why I need a single digit for each of those. Because they're supposed to fit in one place. If I use 2 digits, now it looks like 2 places. You guys start to see what's happening here. So what we do is so smart. We say, we ran out of numbers, let's start using letters. So we say, A means 10, B means 11. How far do I have to go for base 16? J means 12, D means 13, E means 14, F means 15. Do I need G? No, because how would you represent 16 in base 16? 1, 0, yeah. So this number would actually start like this. It would be B, A, base 16. Bah. It would be B, A, base 16. The minute we're above base 10, we understand that letters have to be used to represent double-digit numbers. How we doing?
So
Yes.
it looks like a different method than the problem that you just.
Not a different method at all. In fact, let me do this. Let me let this happen naturally here. Here, let's do this. Let's do the actual problem. Let me do this with a nice clean sheet of paper. So, base 16, 1, 16. The next one would be 256, which is too much, right? So how many 16s are needed in 121? 7. And what's 7 times 16? 112. So then how many ones do I have? No. To make 121 total, right? 7 16s is 112. 9 more makes it 121. Is that cool? So, all I have to do to make this something where I need a letter, let me show you. If I would have made this 123, in fact, let's do that. I want to change 123 to base 16. So I got 1s and 16s, right? 256 is too much. 16 goes into 123. Still 7 times. 7 times 16 is still 112. What's 123 minus 112? 11. Now, if I write this, and that's my answer, that's wrong, by the way. Don't write that shit. How do I know it's wrong? What am I claiming I need? What place is this? 1s. What place is this?
1.
No. What place is this? This is 1. What place is this? 16s. What place is this? So I am saying I need 7 256s, 116, and 1 1. Is that what we need to make 123? I need you to be with me. I cannot put 2 digits because then that's 2 places. Every digit gets its own place. So a number we call 11, in base 16, it's got to be a single digit, so it's only 1 place. So if we just call 11, we call it B. So we understand that if in a base higher than 10, B means 11. Yes? 7B, base 16, yes. And you're all like, I'm so happy. Sorry. What did I do in my life before I knew this? Now, have any of you guys ever done any website stuff? Do you guys know about HTML code? Anybody? In fact, watch. Let me see if I can do this really quick. I got time. What am I rushing for? Here. Can I do it with paint? I think so. So if I choose a color, get out of here. This right here. Look up here. Okay. Oh shit. Can you see that? Okay. Has anybody ever seen this? I'm sure you've played with like changing colors, maybe somewhere, some of you guys. So if I go here, do you see how these numbers have changed? Well, it should have. Why are you not changing numbers? You're disturbing me. There we go. Okay. So if I go to a different color, these numbers have changed. Do you see how there's an F there? So when we represent colors in computer program, which is either called Perl or HTML or Java, so HTML is what a lot of stuff is based on. It uses base 16 to represent the colors. Why does it do that? Because if I have this many places, ones, blah, 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 I can represent a huge amount of colors because each one gets its own designation. Do you guys start to see what I'm saying? So if I just allow each place to have 15 possible values, well 16 because it's 0, I suddenly have a lot of colors that I can give names to. So the computer program knows when I write that code, I mean specifically this color blue. So if I change one piece of this, if I make the F become an A, can I do that directly? I don't know. Then it becomes a slightly different blue. So each place means like red, orange, yellow. So each one tells me how much of each I've got. Do you see where there's zeros? Isn't there 2 zeros at the beginning? It's because I have no red. Probably no yellow either. So 0 red, 0 yellow, but the A has got a lot of frickin' blue. That's the blue position. You guys are all with me. I'm not going to suddenly teach you computer programming. I'm not going to suddenly teach you how to make a web page. If you wanted me to, I'm sorry. But I want you to show at least one real quick place I can show you in the real frickin' world where we use base 16. Base 16 is called hexadecimal numbers. How important is that word? Not. But just in case you hear it, you're like, oh, I know this shit. Okay, coming back. Coming back. There you go. Let me do this kind of fun. Yeah. So what if I had this number? This is a number. It is in base 16, yes? For 2 reasons. I said it, and there's freaking letters. So it's got to be a base higher than 10. What is each place? Yeah, the ones place, 16s, 256. A was 10, B was 11, C is 12. This is acceptable because it's my work. It's not a number, it is my work. So I'm allowed to put 2 digits in one place because I made each place very specific, but we don't write numbers like this. I just want to write the damn number. So that's, again, why I need a single digit in place of 11, 12, 10, 13, 12. How do I put this together to see what number this is? Multiply and add, yeah? And you got calculators, so you can do that stuff. So 12 times 256 plus 10 times 16 plus 11 times 1. Whatever the hell that is. 2,400. 3,072. 3,230.
43.
Ah, man. I didn't add the 11 yet. Okay. 3,000. What is it?
3,200.
Okay. All I know is math, so I like to try to show off when I can. Why? So real quick, do you see how it takes 4 places for us in base 10 and only 3 in base 16? Why does that make sense? Each place in base 16 counts for more, so it can hold a bigger number with less places. Does that make any sense? All right, maybe. This is very similar to Babylonian, except with Babylonians, they allow themselves to put multiple digits in one place. The way that our system works, we can't do that. Yes?
Is there a limit to how high the base can be?
No. In fact, let me just trip you up real quick. We're not going to do this. You ready? We're not going to do this. I can have base pi. You know what pi is? Yeah, come say another. No. Yeah, 34141 blah 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 blah. It's the number you get if you take any circumference of a circle divided by its diameter. You get the same number. It freaked civilizations out. We gave it a special letter because we thought it was from the gods. The gods on high, it's old. Okay. Yeah, that's the drunk history of that. So I could have base pi. I could have base square root of 7. Do you want to? I agree with you. You guys got with me? We're going to focus on freaking whole number bases. And except for like a bonus problem potentially, I'm not going to go above base 16. For your work. Yeah. Okay. Okay. Do you want to, let me see, I have one of two things I could do right now. Do you want to do another example of this?
Yes.
Okay. So what if I have, I want to take 347 and I want to make it into base 13. So if I tell you the base, what does not change is how you make each place, right? You 1 times the base, times the base, times the base. But since it's base 13, I know ahead of time that I might have to use A, B, C, 7, right? So what's the highest single digit in base 13? 12. A is 10, B is 11, C is 12. So C is the highest thing I'm going to use. But I know I'm going to need those because my base is bigger than ours. So I need more single digits. I need all the single digits. Okay, I'll stop. I will stop immediately. So can somebody tell me what the places are? And the next one, now real quick, just to show you. 13 times 100 is 1300. So I almost don't care what the number is specifically. I know this is too big, yes. So when I say go too far, you don't have to write the specific number. You can just go, okay, that's too much, I can tell. And then it's the same work, correct? Now I should have been a little more careful, but let's see if I made one that needs a letter. I didn't really even think about it. How many 169s? 2, good. And I did not make one, did I? Because I suck. Let me think. 338, and that's 9. Darn it. Right, isn't 2 times 169 338? 338. 347 minus 338. 9. So how many 13s do I need? None. There you go. So 209 base 13. If I would have just made it 349, do you see how I would have needed a letter? Because it would have been 2 more, it would have been 11, I would have had to put a B there, yes? Even with the letters, does everyone see how the work is the same?
Yeah.
So if I go from someone else's base, base 7, base 16, whatever, to our base, that kicks ass. Because it's just multiply, add. Put it together. If I go from our base to someone else's base, that sucks rocks. Because it involves division, subtraction. Always the more difficult operations. You guys kind of with me? And we have to, the places are all empty. We have to make sure we go far enough. Does anyone know what base 2 is called? So here's a number in base 2. Yes, that's binary. And it makes sense because how many options are there for every number in base 2 to 0 or 1? The highest single digit in base 2 is 1. What do you think about base 1? Do you think base 1 exists? Because what would the highest single digit in base 1 be? 0. So that doesn't really, we don't talk about it because the poor little dude doesn't exist. Okay. Can you guys figure out what that number is? That's base 2, sorry. Go ahead and figure out what that number is. Don't say it out loud. Go ahead. Yeah, you're good. Oh yeah, I'm sorry. Let me put that in the computer. Rawr. All right, there you are. We only had a couple little things. Otherwise, it was really good. I don't have this up there, do I? We're good. Where are you? So where'd you guys go? It's right there. Must be it. That's weird. Hold on, that's right. 820. Okay, so it's gotta be this one. Okay, yes, okay. Reagan, there. 2.1. Okay. You're welcome.
Wait a minute.
That's interesting. I have two Shelbys in here, I just realized. Alright, so real quick, Abby. Okay. Shelby Gilliland. Shelby Gilliland. No. Laura. Hey. And Adrian. So just to remind you guys, if I say okay, you got full credit, but you might have made some mistakes. If I say correct, that means correct mistakes. You got half credit. If you correct mistakes, you'll go back up to full. And I haven't said this yet, but if I say redo, that means you made way too many mistakes or left too many blank. Yep. When are homework corrections due? Nope. Day of the final. So everything is due the day of the next test. Quiz corrections, test corrections, homework. Homework corrections are due the day of the final. I want you focusing on new homework and do old homework when you can. Final's cumulative, so anything you do before the final helps you. All right, what do we got here? What are the places here? Yeah, 1, 2, 4, 8. All right, Joe. So you got 132 plus a 4 plus a 2. So I got 38. Wow. I like it. One other question, and I'm going to let us out incredibly early, and we are not going to get used to it. What if I ask you this? I want you to change this to base 7. I put one arrow up there, but does anyone have a clue? Do you want to go straight from 11 to base 7? If you can, that's amazing. You could do it. Very good. So what's the middleman? Us. If I can change that base 10, I can then change. So go ahead. And this will be the last problem that we ever do. That we do today. This will be the last problem for today. there, and there. You're good. You're good. Oops. Oh boy, okay, let's see. I'm gonna start to slowly catch up to you. Is this what you guys got? Did you guys get this? So then you got 121 plus 110 plus 3. Thank you. And now I can focus on, so this is like every math teacher's dream is like 2 problems in one. We love that shit. So 234 to base 7, 1, 7, 49,
The number doesn't matter.
too big. How many 49s in 234? 4. And that would be, my brain is dead. 196? Is that right? And then that's 38. Good job, Jim. How many 7s take care of how much 38? 5, and then I have 3 left. 453. So this will be 4, 5, 3, base 7. Dear God, if you do a problem and you get base 7 and you have a 7 or above, you're wrong. You made a mistake. Right? We all know the highest single digit in base 7 should be 6. What's up? Sorry. Oh, I'm sorry. Okay. Is that okay? You could potentially see at least one like that in the homework, right? Okay. I think that's plenty. So you have a long weekend. We don't, we never have class on Monday for us, but the college is closed Monday. Yeah. And I told you, don't get used to it. Okay. Maybe, yeah. But don't forget, I recorded the lectures too, so you could either like not take as many notes here and then take later with the big notes, or yeah, the nice thing is you could speed it up. So you have that option too. But in class, just say, like I said, even if I do with them, I'm like, all right, and I'm like, let's move on. You're like, wait, can we do one more example? I'll do it. It's amazing. Yes.
I have thank you.
What's up?
I'm out of town next Thursday. I'll remind you on Tuesday, but I'm at a wedding, so I have to go. But I'll get notes for someone else.
Okay.
Just
And I forgot to remind everybody we got the first quiz on
on
Tuesday.
Tuesday,
Yeah,
which is great. It's on Thursday. I'd be screwed. So.
Very good point.
Okay, so my first question is number 15. So I did the Venn diagrams for each of those, and then T minus S would just be all of S would be.
Oh, so here's the neat thing. So the answer has to have T, but I want to subtract everything from T that is also in S. So you actually did S minus T. Do you see that?
So then I just basically would shade in all of T.
Yes, like you shade in all of T, but then you erase whatever's in S.
Oh, okay.
So you just get the mirror image of what you got.
So I would basically just do all of this.
Yeah, so it's like the Pac-Man eating the
Okay.
S, yeah.
Gotcha. So if it was S minus T, I would have been.
Then you would have been right.
Okay.
So you,
So then this is not in T and or not in S. Or is,
so
then
this is a good example I was telling somebody earlier. You might want to do two separate things. So not S is this, right?
Okay.
And not T
Is everything that's in S
is this. Everything that's, yeah. So the question is not S
or not T?
or not T. So what that means is your answer has got to have
S and T in it.
everything that is shaded. The only thing that is not
Is the
shaded
little
in
center
either
part.
picture. Do you see that?
Yeah.
So that's the only thing I should not shaded for you is that middle dude.
Because they're not in both.
Because he's not in either one. So it
Okay.
can get in the answer as long as it's in this one or that one. So the only thing that doesn't get in the answer is the intersection.
Okay.
So for some of these, you might want to draw a couple of like preliminary pictures and then combine them.
Gotcha.
Yeah.
And then for this one, since
That's
I
a
already
good
did it
example.
up here and did it backwards, it'd be that. Since technically I did this first on accident.
Yeah, S minus T intersect T minus S. Now the neat thing is, so S minus T would be
All of S.
this.
And then T minus S.
T minus S would be
All of that.
this.
So it'd be everything but.
I'm sorry, I'm being silly.
No, yeah.
No, I'm alright. So S minus T, T minus S. Now, is there anything, so intersect means and. To get into the answer, it must be shaded here and shaded here.
So and in the center.
No. To get into the answer, it must be shaded here and here. Is there any region that is shaded in both pictures? So it would just be an empty, no shading. Nobody gets in the answer because nobody
Because
meets
nobody's
both.
in both.
And is
Gotcha.
very restrictive. You have to meet both things.
So then there would be no shading.
Recording all of our lecture, our discussion.